Apparently, take the cape off my banjo and close this. I'm always worried about open instrument cases. Okay, what I'm going to do is I'm going to take this and I'm going to plop it down right behind. Okay, now if you believe that rockets push off of objects and not off of the air, because I believe that this rocket is pushing off of the air, that it pushes that way. Once the air leaves this thing, it doesn't matter what happens to it, right? That's what I believe. But if you believe that it's actually going to push off of this, shouldn't the force change? And right now there's not a lot to push off of, is there? No, really, there's like, it's kind of hard to push off of that. Well, I don't know, right? The air's going around it or something like that, right? So if I put this down here and it needs to push off of something, it should matter a lot, shouldn't it? Yeah, right? So if we really believe that it pushes off of this, the force should go up quite a lot. I'm just going to pop it down right there. Whoops, there's a magnet on that. That would be bad. Here, let's use the non-magnetic part of this. Okay, here we go. Are we ready? Yeah? Are you ready? Ah! Is it changing? Ah! Do rockets push off the ground? No! They don't push off the ground. They don't need the ground. I can make it read more. Watch this. And then what's happening is, of course, I'm getting so close that they're bouncing off of this and hitting it again. Yeah? Okay? That's why we can get more force. Is that sort of incongruous? Did you expect that outcome? No, this is sort of a weird thing. So when you buy Estes rockets, okay, when you buy them, they give you this launch pad that it launches from. That metal plate is just to keep you from burning the grass. When I launch, guys, can I have your attention? When I launch little Estes rockets, I just take a piece of wire, stick it in the ground like a coat hanger, right? And I just launch them like from a thing like that high. It does tend to light the grass on fire. That's the one drawback, right? Watch the military jets when they launch an air-to-air missile, like Top Gun, right? Is there a little plate behind that for the missile to push off of? No, they just like turn it on, let it go. Go get them. Yeah? Right? There they go, right? Okay. In a NASA rocket, they actually have a thing that it's launching from, but then it weighs many, many tons, and they've got to hold it upright until it can guide itself, right? So they've actually got a flame trench that directs the flames away from the rockets. Okay. So how about on an aircraft carrier? When you see that thing, is that for the airplanes to push off of? No. What is it for? Diverts the air. Yeah, is jet blast a bad thing? Yeah, jet blast is extremely dangerous, and here's the problem. The air is white hot, and it's moving at thousands of miles per hour or something like that, or thousands of meters per second, right? Okay, and the crazy thing about white hot air moving at 1,000 miles per hour is that it looks the same as regular air, right? And there's 5,000 people on an aircraft carrier, and so if somebody walks into that stream of air, right, it's going to incinerate them, right? Or if you look in the background, there's other aircraft parked there, right? It's going to knock the aircraft off the jet. The second thing you need to realize about aircraft carriers is that airplanes don't take off from them, right? The real term is not take off. They're actually launched from aircraft carriers, right? So have you ever gotten those airplanes where you launch them with a rubber band, right? You can, by the way, launch any airplane with a rubber band. You just have to put a little hook on it, yeah, right? But that's how they're launched. If you look, this steam coming up right there, that's a steam-powered catapult. They use actual high-pressure steam from the ship's engines, I think, or something like that, right? And this airplane is sitting there. They clamp it in place. It's sitting there on the catapult. They fire the engines up to full blast, which is a very unusual thing. Usually when airplanes' engines are at full speed, they're moving, right? So this thing's just sitting there going, trying to go, and then they just go boom, and they launch it, yeah? Look at the runways on an aircraft carrier. The launching runway is the shortest one, right? That makes no sense at all, because you need more space to take off. An airplane needs more room to take off than it does to land, correct? Do we know this? Yeah. Do you guys know about the 727 that landed at Troutdale? Yeah. Oh God, this guy landed at 727. Troutdale's this small, like little bitty airport. Gets there and he's like, damn, this runway is short, right? And just stops the airplane on the runway. Well, now you got a problem, don't you? 727 needs a little more runway than Troutdale to take off, right? So they took all the seats out of it. They put as little fuel in the thing as they could, and then they chickened out because it was like they thought they could make it take off, right? but they weren't sure. What? Yeah, they don't use the whole thing, but they need more than Troutdale to do it, right? Troutdale's a pretty short little runway, right? It's for Cessnas and stuff. Right? It just happens to line up with, I believe that was his last day of work. Why did he land there? Because I don't know.
Why they try doing that thing, like tying it down?
Think how many land at the right airport before you criticize them. You know? Okay, there it is. Yeah, blast shield. Okay. How? By the way, while we're on the topic, airplanes don't really land either, do they? It's a weird way they land, right? What do they do? Yeah. Here's the deal, right? You come in. And the only way you can stop in that short a distance is that they zero, you know, like Harrier jump jets can hover, right? But what they've got to do is they've got to catch. There's a cable on the landing thing, right? If you don't catch, there's a tail hook on the airplane. If you don't catch the cable, you can't land, right? Now, if you come in like a normal landing and you come in slow, and you catch that cable just like your jets that you fly on land, right? If you don't catch the cable, you're out of luck, aren't you? You just go right into the ocean. So when they come in, what do they do? Yeah, if they don't catch the cable, they have to fly back out. So as soon as they come in, they got to slow down enough, but then as soon as they come in and they think they're going to catch the cable, they go to full thrust, right? So it's this crazy thing where this airplane with its engines roaring gets hauled down to the deck, right? Like the first exam day here. Yeah. Go try it. Because if they miss the cable, because if they miss the cable, they got to take off again. It's a touch and go. Yeah. Yeah. It's like, and then that deck is pitching up and down, right? That's why Navy pilots are better than Air Force pilots. Are there any Air Force people here? I'm very sorry. People get real touchy about that. Okay. So this is what we get for rocket propulsion. We just take this formula, right? And we just rearrange it this way, right? And we talk about fuel burn rate. Okay, so this thing, we could make another symbol, but I'm just not gonna. Okay, so we could make another symbol, but that is the fuel burn rate, the rate at which we burn the fuel, right? And you could say, and this is the exhaust velocity, right? Right, this is fuel burn rate. And we will start there when we pick up next time. I think I should show you the Jet Blast video. I think it's Top Gear is the funny. I wonder if they've got it on YouTube. We should YouTube it. I know where it is here, though.
You should upload some banjo songs on your YouTube account.
I know. I'm going to wait till I'm good, though. Okay. At the beginning, the audio chunks a little bit, but...
This has got 4 of them. 58,000 pounds of thrust, that's kind of meaningless. How do you get your head round that sort of power?
58,000 pounds of thrust.
Our plan is to drive a car behind the 747 when the engines are at full power. The question is, how far can the engines blow the car off course?
It's not as easy as you might think. It's too dangerous to drive them under here, behind the engines. They have to be well clear. In fact, they have to be way back here, past the tail, and then a bit more. That's a good 50 yards behind the engines.
50 yards.
The first car we'll be subjecting to a good stiff breeze is this Ford Mondeo. Modern, aerodynamic, good at coping with motorway crosswinds. Right, here we go. The pilot is easing up the throttle, building up the power.
He's turning up the middle 2 engines.
Now it's crucial that we release the car at exactly the right time. Because if these engines run at full thrust for more than 20 seconds, they'll start to rip up the runway.
That's the amazing thing. They can melt the runway.